Hello everybody, welcome to EE212 Electric Network Analysis. I hope you have a very good holidays. And so let's start. And this is my first attempt to an online lecture. I hope you will enjoy it, and I also request you to pardon my drawing and writing abilities, as I do not have much uh, practice on this online tool. So let's start. We'll be discussing chapter number 12 from Sudoku's textbook, and it talks about the three-phase circuits. It's the continuation of the uh, point where we left in our last lecture. Just to give an overview, in last lecture we have talked about improving power factor. What exactly is a power factor of a system is, how power is calculated, what exactly is active and a reactive power. um, so let's move ahead. First of all, we'll be talking about single phase circuit, or the circuits which we have seen primarily till this point. uh, Again, let me tell you that we are following Sudoku's textbook for this lecture. So for a single phase circuit, I think that everybody of you are able to identify and make, or have a picture of what exactly a single phase circuit looks like. A single phase circuit have a source, and that source is connected with the help of wires to a load. So this is my load, and this is my source. So this completes a circuit, and say for example current I is flowing, and this source has a voltage of V peak and a phase angle of phi, and this is load Z with a angle of theta. So again, so a load with a voltage, this is load voltage, this is phase angle, and so this is the, remember, this is the phasor notation. And the key assumption of phasor notation is frequency is constant. Means your system have omega radians per second as constant. As constant. So this is one of the key assumptions for a single phase circuit. So for a single phase circuit, we have a source just generating voltage at, say, any value Vp, is having a phase of this, and is rotating the voltage at a constant frequency, is supplying to a load with the help of a different wires or connector. So in that single phase circuit, say this is my VAN, this is A dash, this is N. So this is my complete circuit. So this is also called in literature as single phase two wire system. Remember, so this is a single phase. It requires one phase with A and neutral, and requires two wires, A dash and N. N, small n, capital N are two. So it's also a single phase two wire system. So this is a complete representation of a single phase circuit. Some things to remember. Remember that Vp angle phi is your phase voltage AN. This is also your phase voltage, and so this is a single phase. AN is a single phase, is a single phase voltage. This Vp value is usually given in RMS. Okay, so this is RMS unless until specified. Unless / until specified. So again, remember, few points to take from this Wind a single phase circuit. We have a source, we have a load. This the two terminals of a source are connected to two terminals of load. One is live wire, one is neutral wire. Phase source is generating at a force voltage Vp and have an angle of phase, angle of theta as phase. This is the phasor notation, and it has a constant frequency of omega. And it's also written as phase voltage, for example VAN, or can also be called as phase voltage, and this is the phase notation. Remember, instantaneous time form of this VAN of t can be written as, for example, Vp cosine of omega t plus phi. Fine. So if you have to convert this thing to a phasor, this is the omega constant, or you can also write it as Vp sine of omega t plus phi. It depends upon Vn of t. So this is or, either or. Okay, so this is an overview of what we have been studying till now. Let's move forward.